Hello everyone, this is our third Q-Learning Survey project update. This week, the focus was not on simply adding more papers. Instead, we worked on connecting several parallel streams of work into one shared survey architecture, the modern Q-Learning diagram, the evolving shared draft, and Logan's deeper continuous control analysis. This week was mainly an integration week. We had several useful pieces developing in parallel: offline IL nodes, multi-agent value decomposition work, benchmark analysis, and Logan's continuous control survey. The most important progress was making those pieces fit together rather than leaving them as isolated summaries. First, we refined the modern Q-learning diagram so each branch follows the same pattern. A deployment regime creates a new challenge, which motivates specific mechanism families and representative methods. Second, the shared draft structure is becoming clear. We are not committing to final pros yet, but we now have natural places where stronger nodes can eventually become markdown sections in the draft pipeline. Third, Logan's continuous control work gave us a much richer technical structure for one of the four branches. So now, this is the updated modern Q-learning map. The four branches are offline learning, language and sequence models, multi-agent learning, and continuous control. The point of this diagram is not to claim that every method belongs in only one category. In fact, some overlap is actually meaningful. For example, BCQ, CQL, IQL, and CalQL appear naturally in offline IL, but they're also highly relevant to continuous action spaces because they determine which actions a critic can safely trust. The map gives us a shared language for the survey, deployment regime, then challenge, then mechanism family, then representative methods. That is much more useful than a long chronological list of algorithm names. Now, we have the shared draft update, which is offline RL and multi-agent RL. The shared nodes, the Google Doc, have become more structured in two areas. For offline RL, we now separate four mechanism families. The first family constrains action towards the dataset support, including BCQ, BEAR, and TD3 plus BC. The second family penalizes unsupported values, represented by CQL. The third avoids explicit maximization or potentially out-of-distribution actions, represented by IQL. Finally, AWAC and CalQL help bridge offline pre-training toward later online improvement. For multi-agent Q-learning, the story now goes beyond simply VDN and QMIX. We begin with independent Q-learning, then additive decomposition through VDN, then monotonic mixing through QMIX, and then more expressive approaches such as QTRAN, Qatten, and QPLEX. This gives us the section a real technical progression. How do we increase coordination expressiveness while still allowing decentralized greedy execution? Now let's look at Logan's continuous control synthesis. His work helped us reframe continuous control Q-learning around one central problem, making the continuous action in argmax safe and trackable. The first family stabilizes value estimates. RedQ, TQC, and DrawQ addresses critical estimation and instability, especially when learning uses aggressive replay or high update to data ratios. The second family controls trusted action support. VCQ, CQL, IQL, and CalQL prevent the critic from freely maximizing of actions that are unsupported or unreliable. The third family changes how actions are represented or generated. NAF, FSQ, QTransformer, and diffusion QL each make the action space more manageable in different ways. The fourth family ranks a finite candidate set rather than solving a global continuous maximization problem. QTOPT uses cross-entropy AMP-style approach, where Expo and Expo FT use policy-generated or edited candidate actions. This is valuable because it shows that continuous control Q-learning is not one trick. It is a design space involving critic stability, action trust, action representation, and candidate selection. Now, why the shared architecture matters? This shared architecture helps contributors because everyone can see where their work fits, where overlap is expected, and where there are still gaps. It helps the manuscript because our final survey can make mechanism-level comparisons rather than simply introducing methods one by one. and helps readers because methods become easier to interpret as responses to concrete weaknesses. For example, offline IO is about trusting a fixed dataset, multi-agent Q-learning is about coordination under decentralized execution, and continuous control is about safely maximizing values over complex action spaces. The overall project is becoming a map of design choices and trade-offs, rather than only a catalog of algorithms. Finally, the next steps. The next step is still not to rush into final manuscript prose. First, we need to verify the new summaries and make sure the mechanism labels are accurate. We also need to refine the diagram wording so it stays readable at paper scale. Then the strongest pieces can be converted into more formal section outlines and eventually into dedicated markdown files in draft pipeline. Logan's continuous control synthesis can become a deeper technical subsection. The benchmark work can later become an Atari section plus a beyond Atari carriage section. The main message this week is that we are building the structure first. Once the structure is trustworthy, writing and integration should become much easier. That's all for this week. Thank you everyone for listening.